beginning, man has struggled ever onward in his conquest of time and space. For countless centuries, lofty mountains mutely challenged him, standing as stalwart barriers across his path. Upon the oceans that surrounded him, he launched his ships. At the mercy of wind and tide, they made slow headway across the waters. Over the lowlands, the wilderness of desert and green valleys, he plodded his very way, earthbound in the conquest of time and space. But man is no longer earthbound, and Lockheed rides the airways with a thrust of bright propellers and the flash of gleaming wings. And behind this Lockheed lies aviation history. In 1903, on the plains of Kitty Hawk, North Carolina, this history began. In the granddaddy of all modern planes, the Wright brothers won immortality by sustaining flight in a heavier-than-air flying machine. There is no fuss or ceremony, no cheering crowds. The motors sputter and catch, weights drop, the ship catapults off the ground into the air for the first flight on record. Since then, aviation history is written in a never-fading book of records. In 1928, a Lockheed Vega, the well-known Yankee Doodle, reaches New York from Los Angeles in 18 hours and 58 minutes. At the controls are Colonel Arthur Goebel and Harry Tucker. In 1929, Captain Frank Hawks climbs aboard his Lockheed to set a new transcontinental mark. Good luck, Captain. New York is only 3,000 miles away. Off on his way to a new record, one of the many he is to establish in the years that follow. Into the cockpit of his Lockheed Sirius climbs Colonel Charles Lindbergh. Mrs. Lindbergh is with him. Flying together, as always, they are heading from Washington, D.C., across the Bering Sea to Japan. A perfect landing after almost half the world has rolled by beneath their wings. Cheers and waving flags as Tokyo greets them. That same year, 1931, Ruth Nichols lands her Lockheed Vega after establishing a new feminine altitude record of 28,743 feet. Nice going, Miss Nichols. 1933, a famous Lockheed, the Winnie Mae, carrying a famous flyer, comes home from a solo flight around the world. What an achievement for Wiley Post. First man to fly around the world alone, and first to fly around the world twice, both times in a Lockheed. Colonel and Mrs. Lindbergh are starting on another and perhaps their greatest journey, a 29,000-mile survey flight from New York to Labrador, Greenland, Iceland, Europe, the Azores, Africa, Brazil, and return to New York. 1934 finds Sir Charles Kingsford Smith, together with Captain P.G. Taylor, completing a 7,000-mile trip from Australia to Oakland, California. It is the first crossing of the Pacific from west to east, and Sir Charles, in his Lockheed Altair, the Lady Southern Cross, has made it in less than 55 hours. This great flyer and great plane certainly deserve congratulations. In 1935, Amelia Earhart flies her Lockheed from Honolulu to Oakland. She is the first woman to make a solo flight over the Pacific, covering the distance in 18 hours, 16 minutes. The crowd hails her for an outstanding performance. 1938, Howard Hughes hurries to his plane for the start of his race around the world. 3 days, 19 hours, and 9 minutes later, his Lockheed brings him back to New York and a new record. In less than 4 days, he saw 5 sunrises, and the plane actually beat the revolution of the Earth on its axis. Records and more records, and these are just part of a long list. But exciting as they are, they mean nothing to the true goal of aviation unless the experience gained is applied to further the speed, safety, and all-round performance of air transportation. And with the cooperation of the pilots who made these famous flights, Lockheed has been able to achieve that performance and create new standards of efficiency. That was true in the development of this Electra, which was Lockheed's first all-metal bimotor transport. It made history on the air lanes of the world, and every subsequent model has lived up to its tradition. Here is the 12. It is a smaller ship, accommodating 6 passengers and answering the proven need for a plane that can combine economy with the performance of a large airliner. This Lodestar is a luxury transport. Certainly one of the best looking, it is today probably the fastest commercial ship on regular airline service. And for the convenience of all customers, service and parts depots have been established throughout the world to maintain the peak performance of Lockheed's vast fleet. And in all corners of the globe, 24 hours of every day, these ships fly the airways in routine flight, confidently accomplishing the jobs for which they were built, the conquerors of time and space. Lockheed over North America, United Airlines, Continental Airlines Incorporated, Mid-Continent Airlines Incorporated, Northwest Airlines, Chicago and Southern Airlines, Braniff Airways Incorporated, National Airlines, Delta Airlines, Boston Maine Airways Incorporated, Trans-Canada Airlines, Pacific Alaska Airways. Lockheed over Central America, Líneas Aéreas Mineras, TACA, Cia Nacional Cubana de Aviación. Lockheed over South America, Pan American Airways Incorporated, KLM, Air France, Avianca, Línea Aeropostal Venezolana. Lockheed over Africa, Air France, Air Afrique, Aéro Maritime, South African Airways, DETA. Lockheed over Europe, British Airways Limited, Aer Lingus Terranta, KLM, LOT, Aeroput, LARES, Romania, Air France. Lockheed over Asia, KLM, KNILM, Japan Air Transport Company Limited. Lockheed over the Antipodes, KNILM, McRobertson Miller Aviation Company, Guinea Airways, Ansett Airways Limited, WR Carpenter Airlines, Union Airways of New Zealand. Lockheeds also serve high government officials of the Netherlands East Indies, Mexico, Venezuela, Brazil, Argentina, Australia, Canada, Great Britain, India, and the United States. Worldwide coverage, but it has not been accomplished in a day. It is the result of a smooth-running combination of men and machines. In that combination lies the story of Lockheed itself. It is a success story, modern, exciting, typically American. The Lockheed Aircraft Corporation plant, Burbank, California, in 1926. And today, the same company, the same location, but quite definitely not the same plant. As recently as 1932, sales aggregated the overwhelming total of $23,298.03. In 1940, actual deliveries amounted to more than $42 million, and conservative estimates indicate that in 1941, this figure will be more than doubled. And to the men of Lockheed belongs a large share of the credit, to their skill and to their loyalty. They are a cross-section of typical American workmen: drillers, riveters, tool makers, die casters, machinists, and technicians. In 1931, there were only 300 of them. 1941, over 35,000. Every man who checks in, from office boy on up, has taken and passed exhaustive tests covering intelligence, temperament, and special aptitude to prove his individual ability. 35,000 American workmen, the right men for the right jobs to build the best planes. This is not a trick shot made with mirrors. It is the drafting room of the engineering department, where every new Lockheed has its beginning. A beginning conceived with the purpose of supplying the answer to definite needs of the aviation industry. To attain this goal, over 850 engineers make over 5,000 drawing plans, devoting a total of over 200,000 work hours to their mission of creating one new design. The component parts of a modern airplane's wing, fuselage, and tail surface are almost countless in number, yet every single one of them must be engineered. Even the most minute part receives the greatest attention. 4 separate drawings are made showing detail from 4 different angles. Although the part is no larger than a silver dollar, it will have to go a great deal further. The interior of a plane is one feature of design seldom associated in one's mind as coming under the supervision of the engineer. Yet one of his most important jobs is to provide utter comfort for passengers traveling through the air at high speeds. The Lodestar's cabin has been designed for this comfort. Inside, the sound of powerful motors is reduced to a pleasant hum by scientific soundproofing and vibration control. Restful chairs, ample space, and headroom are results of thoughtful planning, and all Lockheeds are especially adaptable to the requirements of private owners. For businessmen to whom time means money, the Lodestar is convertible into a convenient and dependable office in the sky. The compact 12 becomes a comfortable lounge for attending important events anywhere at any time. The cabin of Lockheed's new four-motor transport, the Excalibur, will look very much like this. Although the plane is still under construction, the engineers have built an exact replica, known as a mock-up, out of wood. In this way, every possible detail of passenger comfort can be effectively predetermined and applied. But the ideas and plans that this man and the hundreds like him put into execution are not only those of Lockheed's chief engineers, but those of the entire flying world. For the Market Research Division maintains close contact with the operative branch of the industry. The staff compiles lists of important features relating to a plane's design. These findings are set up in the form of questionnaires. If you were to build your own ship, on the flight station, where would you locate emergency controls? On the engine control stand, where would you put the levers and the rudder pedals? These comprehensive questionnaires are sent to airline executives, pilots, transport officials in every corner of the world. To Trans-Canada Airlines, R.C. McLeod in South Africa, Tri-American Aviation, Buenos Aires. The list is almost endless, but to mention a few more, American Airlines, Lieutenant Thatch, VP-5 Squadron Canal Zone, and British Airways. The replies to these pamphlets are carefully sorted, for they represent knowledge gained under actual flight conditions. Detailed graphs and charts are compiled by competent statisticians. No suggestion is too small. Every answer to every question is checked and noted. These findings are recorded in another pamphlet. You told us this is the way you would do it. On flight station, on engine control stand. And on rudder pedals, we asked, are brake toe pedals desirable? 93% said yes, 7% no. That verdict is submitted by men whose combined opinions represent the experience of over 16 million hours of flying. These practical viewpoints, as gathered by market research, are submitted to the engineers. They combine these ideas together with their own creative ability in the conception and building of every new Lockheed plane. That's how Lockheed designs airplanes to suit the men who know airplanes best, operators, pilots, and regular airline passengers. And the first form a new plane takes is on paper. From these drawings and thousands like them, an exact scale model known as a wind tunnel model is made and is connected to instruments which determine its flight characteristics. The model is hand-carved, accurate to the fraction of an inch, weighs over 500 pounds, and costs more than $5,000 to build. The door is closed, the wind tunnel sealed. A flip of the switch and the wind propeller whips up to speed. The model is exposed to a far higher velocity than this 90-mile-an-hour wind. The small wind tunnel model is actually subjected to and withstands a much greater force. From an idea to an actuality, from theory to fact, from a model to a completed Lockheed, the plane has been built. More than that, into it has been built the strength, ruggedness, and durability necessary for its safety and high-speed performance. But not so long ago, this shining plane was only a small part of a trainload of metal addressed to Lockheed. For the metal inside these wooden frames is the stuff that planes are made of. Hard and strong, it must be fabricated by men and machines into the parts that make airliners. Giant shears act as huge mechanical scissors. Metal sheets are slipped into place. The sharp blade strikes and cuts through them as if they were cloth. The high-frequency router, a dental patient's nightmare, turns 15,000 revolutions a minute and cuts layers of metal into their first rough shape. The bit turns so fast that it must be cooled by a constant stream of oil. The massive hydro press exerts an overall pressure of 9 million pounds, and it literally squeezes parts out of metal. An endless chain of roller conveyors carries a tray with the forms to workmen. They put the metal which has already been cut to the correct size in place on the forms. The tray now continues on its way into position under the press. The operator touches a switch, the press starts down, and look out below. Almost unbelievable pressure, an irresistible force, but under perfect control. And where plain sheet metal went in, finished parts come out. The hydro press turns out more parts in 1 minute than 2 men could complete in a whole day, and turns them out better and more accurately. A compressed air stamp which forges metal is an excellent example of powerful machinery under absolute control. Taps as gentle as a tack hammer, then the crushing impact. What a nutcracker this outfit would make. And yet its control is so delicate that it can crack an egg, at least so the operator claims. Look out there, a little too hard and you'll have an awful mess. Be careful. Well, hello, stranger. You certainly have a brand new kind of a mama. Skilled men and precision machines have fabricated these parts, but even metal can be strengthened and protected. To do this, there are several types of processing. Complete electrochemical anodizing baths provide parts with a protective coating of oxide film. This is a safeguard against the threat of corrosion caused by moisture. It is an interesting fact that these parts are protected against any harmful effects of moisture by being given a bath. Another type of bath is used for a different purpose. In order to harden and thereby strengthen certain parts, they are immersed in a hot salt solution of sodium potassium nitrate. In large ovens, other parts are hardened by baking at 1550 degrees Fahrenheit and quenching them in oil. It is easy enough to say that these parts, which will eventually be the plane, are strong. To prove that they are, to constantly guard the Lockheed measure of strength is the duty of the testing laboratory. A spectrograph is one of the most modern scientific testing devices. It analyzes the purity of the metal alloys which go into a plane. Tremendous heat created by an arc burns sample filings of the metal. These filings are placed in a cavity on the lower of 2 acid-treated graphite electrodes and then burned. The light of the burning metal passes through a lens and then through a rotating sector, the adjustable opening of which controls the amount of light falling on the slit. The light now passes through the slit and falls upon a diffraction grating. This diffraction grating is a concave aluminumized glass plate on which 24,000 lines per inch have been ruled with a diamond point. The light is separated by the grating into wavelengths. These wavelengths, or light rays, fall upon a strip of film, and a photographic record of them is thus produced. Since each element has its own wavelength, from the developed film it is possible to determine exactly which are present in the alloy. In this manner, the spectrograph immediately detects all impurities, and any inferior metal is promptly discarded. The sole purpose of this huge machine is to break things. Its powerful jaws, capable of a compression of 300,000 pounds, are about to crush a small section of the wing in order to measure its resistance. Now watch carefully. The upper jaw is clamping down with an invisible, relentless force on the seemingly frail strip of metal. But actually, just how frail is it? 60,000 pounds? 70,000? There it is, a slight ripple. The breaking point has been reached, and it takes a pressure of over 80,000 pounds to even bend this frail little section of a wing. For contrast, let's see what happens to a solid cylinder of concrete, which certainly appears much stronger. There is the first crack, and the concrete shatters completely under a pressure of less than 75,000 pounds. All stressed parts, such as forgings and castings, are X-rayed for any possible flaws in the metal. Lockheed X-rays more parts than all other aircraft manufacturers combined. They may look new and shiny on the surface, but that doesn't matter. What are they like underneath? This batch is fine, perfect. A different story here. Those slight, almost imperceptible flaws which doom it to the scrap heap would be invisible to any eye other than the X-ray. Therefore, although it is important to know what is on the outside of a plane, every stressed part is X-rayed because Lockheed thinks it is even more important to be absolutely positive of what is on the inside. Yes, every part of this plane is built for the strength, ruggedness, and durability to achieve the highest speeds. And there goes the Lodestar. Carrying a full load of 17,500 pounds, it speeds down the runway for the takeoff. In 15 seconds, after a run of only 860 feet, it leaves the ground and soars into the air. Climbing rate 1,200 feet per minute. And while the plane is in flight, the dials and indicators on the panel are the guides by which a pilot flies. Over a half a mile of wire connects them with the controlling instruments, which must be infinitely accurate before they are installed. In the instrument testing laboratory, each instrument and accessory is, to all intents and purposes, actually flown before being installed on the plane itself. For instance, on this stand, a motor duplicates the swing of a plane to test the turn and bank indicators. Here, tachometers are also tested, and propeller governors, vacuum pumps, fuel pumps, starters, generators, and hydromatic motors for feathering propellers. The automatic pilot is checked by a vacuum system against mercury manometers. This small box can guide a plane in flight, keep it as true to its course as the most experienced pilot. An airplane is a chain of which the thousands of separate parts are the links. They must be forged together in order to shape the wing, the tail, and the fuselage. The duty of the wing is to provide the lift that sustains the flight of an airplane. Here in the plant, it must be assembled as flawlessly as it was designed. Although a wing is generally considered as a unit, it is really composed of 3 parts, 2 outer sections and the center section. We are all familiar with the general shape of a wing, but while an outer section is in the first stages of assembly, we can get a good idea of the complex structure on the inside. Every rib and crosspiece has its purpose. Remember, it was just a small part of the wing that we saw withstand a compression of 80,000 pounds. Each operation is executed with precision and care as the outer section moves down the production line and takes shape. High-speed electric drills punch holes for the rivets. There are more than 700 drillers or riveters who have all had previous training. Even so, before they're assigned to actual production, they must attend Lockheed's own school until they can uphold the plant's standard of efficiency and skill. There are more than 50,000 rivets on a completed wing, and every one of them is checked, examined, and checked again. This requires an army of over 200 inspectors, such as this one. But by the time a Lockheed plane is assembled, every square inch of it has been inspected at least 5 times. Inspector number 158 finds this row perfect and okays it. And the story of one outer wing section is the story of 10, of 20, of 1,000 sections as they move down the line in an endless parade. Mass production with the emphasis on precision and quality. The assembly line for the center section of the wing is one of the largest and most vital units in the plant. It has to be because the center section is the strong man of the plane. It must be constructed and assembled so as to be able to support heavy loads and to withstand great strain, for it unites the 2 outer wings with the fuselage. The fuselage will eventually rest in the gap between the 2 shoulders, and the wings will be joined like arms on either side. The main beam of the center section is the strongest part, the backbone of the entire plane. Like a bridge, it must carry any burden with steadfast dependability. And the main beam is built just like a bridge. At all times, it carries all of the flying load, the engine load, and the landing load, and it is stressed to support more than 5 times the total weight of a fully loaded plane. Completed and assembled, capable of supporting a static load of 70,000 pounds, the wing will do its job as the men who built it have done theirs. The tail surfaces control the maneuverability of a plane. The use of twin rudders was developed by Lockheed and are one of the distinguishing features which point out every Lockheed. The fuselage is the body of the plane. It represents the final word in aerodynamic design and streamlining. And during construction, these basic principles are built into the fuselage and applied to every operation from the beginning to the completed shell. As the first step in its assembly, the bulkheads are joined together by stringers, which form the basic shape and strength of the fuselage. Skin fitters then fit and shape the metal sheets, attaching them with removable fasteners. On their heels come the riveters, while every stage of the assembly is constantly under the close check of inspectors. Assembling with electric continuous spot welders facilitates production and gives many fuselage parts an extra smoothness for better streamlining. With an eye to the future, Lockheed is constantly enlarging on this process because better streamlining means greater speed. And so another fuselage is finished and ready for mating with the wing. Like a ship being launched, it moves slowly down the ways. Slowly now, yes, but for just a little while longer. Soon sunlight will be glinting from its metal sides. Its nose will point upwind. In the comfort of its cabin, passengers will read or write or sleep or think after their own fashion, and beneath it, the lakes, rivers, and valleys of the countryside will unfold. Slowly still, the fuselage is lowered into place, united with the wing, and now, slow no longer. Speed on the water. Speed on the snow. Speed on wheels. On rails. Speed on wings. There is truth in the slogan that it takes a Lockheed to beat a Lockheed. And as the plane approaches the field, it slows down for the landing. The Fowler flap has been adopted and developed by Lockheed. The flap gives a greater lift to the wing and provides a brake action to reduce the speed. The plane lands at 65 miles an hour, and from a height of 50 feet, it can come to a complete stop in less than 600 yards. This Lockheed Lodestar, with its safety, its comfort, and its great speed, typifies the ideals of aviation in America. To protect these ideals, Lockheed is contributing its share toward national defense and the defense of democracy in other parts of the world. These B-14 bombers, better known as the Lockheed Hudson bombers, are rolling off the production line at an ever-increasing rate. They have been ordered in great quantities by Great Britain and Australia. When ready for delivery by boat, the Hudson bombers are dismantled. The sleek fuselages are carefully encased in canvas, and the wings, already stowed away below deck, are crated in wooden frames for safe shipment. When the planes reach their destination, they are easily reassembled and soon ready to take their places in the staunch defense of the British Empire. And while these planes start on their long journey by water, others are being given their final test flights for the tough job ahead. And still more are winging their way directly toward Canada. In combat, in actual line of duty, the Hudson bombers have won a name for their efficiency and dependability. And as America builds its planes for commerce and for defense, it is well to remember that Americans invented the airplane and developed the modern conception of mass production used by Lockheed. And out of the vast production line come Lockheed's, the 212, the Electra, the 12, the Hudson bomber, the Lodestar, and now Lockheed's answer to the challenge of our times, the Interceptor Pursuit P-38. It has been developed solely for national defense, and Army officials consider it the fastest military plane in the world today. The P-38, a man-made comet. The P-38 is a completely new development in conception and design. The purpose of this deadly single-seater fighter is to prevent any would-be attacker from reaching his objective. Lockheed is building vast quantities for the United States Army, and many of its features are closely guarded military secrets. But it can be revealed that the P-38 will climb a mile in a minute, and its motors are so quiet that it can approach any target almost without warning. And as wings soar higher above America, so are soaring the hopes of free men the world over. For they know that whether it be for commerce or defense, ship for ship, American planes have no equal. And just as Lockheed commercial transports serve the people, so do the Lockheed military planes stand ready to serve should the need arise. The striking power of Hudson bombers, the speed of the P-38, envisioned by Lockheed, engineered by Lockheed, built by Lockheed. Wings of eagles for the protection of our country. Wings of progress for the prosperity of our people, today and tomorrow. And the airplane of that tomorrow, who knows what it will be, for the march of aviation has been so swift. But whatever it is, the world will look to Lockheed leadership then as it looks to Lockheed for leadership today.